Welcome to the Deep Dive. Today we're jumping into something pretty fundamental to our digital lives, but maybe something you don't often think about. High-performance data storage.
Yeah, it's kind of the unsung hero, isn't it? It's what makes everything fast and responsive.
Exactly. Like what makes your streaming service load instantly, or your bank app work in a second. A lot of that is down to really smart storage design. And what's cool about this deep dive is where we're getting our info. We're actually looking at an exam prep guide.
Right. For the PowerMax Design V2 certification, the D-PVM-DS-01 exam specifically.
Now, I know what you might be thinking, exam guide, that sounds super technical. And, well, it is. But trust me, the ideas in here, they're fascinating. And they really show you how things work under the hood. It's not just for IT pros.
Absolutely. Our goal here is basically to pull out the key insights, the really interesting bits from this guide, and make them, clear and easy to grasp, even if you're not designing data centers for a living.
Yeah, we want to give you a shortcut, really. A way to understand the crucial decisions behind that hidden infrastructure that makes, well, everything digital possible.
So you'll get a sense of why things are built the way they are.
Okay, let's dive in. Picture this scenario. You're designing storage, right? And you've got this super important database.
A critical one.
Right, critical. And the main thing is it needs really low latency, like near instant response times.
Okay.
So the question is, what kind of service level objective and SLO would you assign to that? What tells the system, hey, this one's important?
Okay. For something that critical, with that strict low latency need, You're going for the Diamond SLO.
Diamond. Okay, why Diamond? What makes it special?
Well, Diamond is the absolute top tier. It's designed specifically for the fastest possible performance, the lowest latency. Critically, it ensures that workload gets the highest priority on the entire storage system. No queuing, basically.
So it's like the VIP lane.
Exactly. It often means dedicating specific physical resources, like certain flash drives or cache, just for that workload. It's not sharing resources in the same way lower tiers might.
Got it. So it guarantees that top speed,
Yeah.
which makes sense for a critical database.
Precisely. It highlights how important it is to have these different service levels you need to prioritize.
But hang on, if Diamond's the best, why not just use it for everything? What's the catch?
Well, the catch is resources and cost, ultimately. Dedicating those resources means they aren't available for anything else. So it's the most resource-intensive option.
Expensive, in a way.
Yeah, in terms of system capacity and dedication, you wouldn't put your, say, archive data on Diamond. That would be overkill and wasteful.
Wait, you match the tier to the need.
Yeah.
Low priority stuff doesn't need the VIP lane.
Exactly. Strategic allocation. It's all about balancing performance needs with efficiency and cost, not one size fits all.
Okay, that makes sense. So Diamond SLO sets the performance goal. Now, how do we actually connect things? Let's say an administrator is using Unisphere for PowerMax to set up storage for a new server. What's the absolutely essential first step before they can map a storage volume to that server?
Right. Before you can map any storage, that host, that server, it must be added to a host group.
A host group, not directly to the host itself.
Nope. You can't map a volume straight to an individual server, not typically in these enterprise systems anyway. Think of the host group like a container, or maybe a distribution list.
Okay.
You put the server's connection points, its initiators, into this group. Then you map the storage volumes to the group.
Ah, I see. So everything in the group gets access to the same storage.
Exactly. All servers within that group inherit the access to those volumes.
And why do it that way? What's the benefit?
It's all about organization, management, and control, especially when you have lots of servers. Instead of managing permissions for hundreds of individual servers, you manage them at the group level. It's way more efficient and less error-prone.
Scalability, too, I guess.
Absolutely. Makes adding new servers or changing access much simpler. It's a fundamental concept for managing storage at scale, really. Good organization.
Okay, host groups make sense. Logical containers. Now, let's shift gears a bit to data replication. Keeping data safe.
Always critical.
Right. So imagine you have a PowerMax array, and it's doing synchronous replication, SRDFS, to a disaster recovery site.
Okay, so every write is copied immediately.
Exactly. But here's the problem. That synchronous replication is actually causing I/O latency. It's slowing down the applications using the primary storage.
Yeah, that can happen, especially over longer distances, the waiting for acknowledgement part.
So what can the storage admin do? They need to relieve that latency now, but they probably don't want to just stop replication entirely. That seems risky.
No, you definitely don't want to stop it if you can avoid it. The immediate fix here is to change the SRDF group mode to semi-synchronous.
Semi-synchronous. Okay, what does that do differently?
So with synchronous, the primary array waits for the OK from the remote site before telling the host the write is complete. That's the source of the latency. Semi-synchronous mode changes that. It lets the primary array acknowledge the write back to the host immediately as soon as it's secure locally in cache or on disk.
Ah, so the host doesn't wait for the round trip to the remote site.
Precisely. The replication still happens in the background, the data still gets sent to the remote site, but the host application doesn't feel that network latency anymore.
So it provides immediate relief.
Immediate relief, exactly. It decouples the host write acknowledgement from the remote write completion. It's a temporary measure, usually, to get performance back up without sacrificing the replication flow entirely.
That's a really smart mechanism, a way to kind of buffer the impact.
Yeah, it's a great example of building in flexibility, balancing the absolute need for data consistency with the practical need for performance. It's a trade-off managed by changing modes.
Very cool. Okay, so we've talked performance tiers, connections, and managing replication latency. What about just efficiency, dealing with the sheer amount of data?
Yes, data reduction, always a big topic.
So if an admin is creating a new storage pool in Unisphere, and they specifically want to use things like deduplication and compression to save space, what type of pool do they need to choose?
For that, they need to select a data reduction-enabled pool.
Makes sense, the name gives it away.
It does, and when you choose that, you're basically telling the PowerMax, okay, be smart about the space you use for the data in this pool.
And how does it do that? What are the mechanics?
It primarily uses two techniques, deduplication and compression. Deduplication is clever. It looks for identical blocks of data. If it sees the same block multiple times, even across different files or servers using that pool, it only stores it once.
And just points to it?
Exactly. It keeps pointers. Think about how many copies of the same operating system files might exist across hundreds of virtual machines. Dedupe finds those.
Okay. And compression?
Compression just takes the unique data that's left after dedupe and shrinks it down using algorithms, like zipping a file.
So the combination can save a lot of physical disk space.
Oh, absolutely. Significant amounts. We often see reduction ratios of 3-to-1, 5-to-1, sometimes even higher depending on the data type.
Wow. And that's not just about buying fewer disks, is it?
Not at all. Less physical storage means less rack space, less power consumption, less cooling needed. It has a big impact on the overall data center efficiency and cost. It's a huge win.
It really makes storage smarter, not just bigger.
That's a great way to put it. Intelligent storage.
All right, one last area for today. Let's talk about something that can creep up on you, old data cluttering things up, specifically snapshots.
Yes. Snapshots are incredibly useful for backups and testing, but they can accumulate.
Right, like forgetting to delete old photos off your phone until it's full. So with PowerMax's snapshot feature, TimeFinder Snap VX, is there a way to automatically clean up old snapshots so they don't just sit there forever, eating up space?
Yes, absolutely. There's a parameter you can set when you create the snapshot or even apply later. It's called time to live, or TTL.
Time to live, TTL.
Okay. You basically set an expiration date on the snapshot. You tell it, okay, keep the snapshot for, say, 7 days or 30 days, whatever you need.
And after that time?
Poof! The system automatically deletes it. No manual cleanup needed.
That seems essential for good housekeeping.
It really is. It prevents that silent storage growth from forgotten snapshots, which can genuinely cause performance issues or even fill up your storage unexpectedly if left unchecked.
It highlights how important automation is in these complex systems, doesn't it? Taking care of the routine tasks to prevent bigger problems down the line.
Definitely. Proactive management through automation.
So maybe a final thought for you, our listener. Consider just how much clever engineering goes into the parts of our digital world we barely notice. Every click, every transaction relies on systems making these deliberate trade-offs: speed versus safety, cost versus capability.
Yeah, think about other systems you use daily. What kind of hidden optimizations might be happening? What trade-offs are being made, behind the scenes on your behalf?
Something to ponder.